In this video, we'll discuss mesh sizing, quality, and convergence in ANSYS Workbench 14.5. We'll be using the same model as the mid-surface body connections video also found on this site. To review, we have a symmetric mid-surface model that has 1000 Newton loads applied to patches, and it's constrained about the plane of symmetry. However, we'll be focusing only on the top half that has the continuous body instead of dealing with the hybrid of averaged and unaveraged results on the bottom half. In this results view, with the mesh shown, we can visually check for misshapen elements or undesired elements. Here you can see several quad elements that are far from square, and several tri-elements have been included in the mesh where the mesher was not able to create quad elements. Now we can click on the mesh node in the tree, scroll down to the mesh metrics, and look first at element quality. This is a composite metric of how close it is to the perfect shape, one being optimum. And the perfect shape for a quad element would be a square, and the perfect shape for tri-element would be perfectly triangular. We can make the mesh metrics easier to navigate by clicking on the controls and taking the max number of elements down to a much smaller number. In this example we use 10. This makes the various value bars much more accessible with a mouse click. Here the worst quality quad elements are shown, and you can see why. They're basically triangular. The next set of quad elements are quite skewed. The next are skewed to a lesser degree, but this is a long and important area that we'll be using for stress extraction. We can also look at other matrix like aspect ratio, and again we'll change the controls to make the mesh metrics chart more usable. For this measure, the lower number is actually more desirable. We want aspect ratio as close to 1 as possible. We can also take a look at unaveraged stress results. What we might be looking for here are areas where the color bands skip several bands in between. There's not a continuous transition between adjacent bands on the legend. Like most other results interpretation, this is quite subjective, but one practice to use would be to keep the default 9 color bands and look at the stress values from 0 to your critical area of interest. To the right I have different mesh sizes, more refined meshes, and we see we still have some adjacent bands or adjacent elements that cover multiple bands. As we continue to refine further, you see the skipping of color bands disappears. Note in this final refinement there was no benefit from the adjacent element color band check. I extracted stress values from that weld line we are examining, and you can see as the mesh size gets smaller, we do converge upon a value of 122 megapascals, and that was actually achieved at the next to last mesh interval. So as was seen a few moments ago, there was actually no benefit from going from a 5mm to a 3mm mesh using the color band test, and the convergence on stress shows the same result. Convergence criteria is also subjective, but typical values used are 5% and 3%. And it is going to be dependent on the purpose of the analysis and the analysis goals. In conclusion, a quick visual inspection of your areas of interest can give you a good idea of potential meshing issues, particularly with mesh quality, but also mesh size. Mesh quality statistics in ANSYS can be useful in identifying potential quality issues on a larger scale. Altering the y-axis scale to a smaller number of elements can help interaction with the quality metrics graph. Element quality is a good overall composite statistic to use that checks to see how close the element is to perfect, be it square, triangular, or some other shape. Other common quality metrics are available, such as aspect ratio and skew. Acceptable values are subjective, and many opinions can be found with internet searches. A look at unaveraged von Mises stresses can show quality in mesh sizing issues. This is subjective, but one recommendation is to look for adjacent element skipping color bands with a default 9. Convergence studies can also tell you about the quality of your mesh. Targets for convergence are dependent upon your analysis goals, whether that's comparative, correlation activities, or other reasons. Thank you for watching, and have a great day.